Okay, guys, picking back up in lesson 6.2, right? I think that's where we're at. We are working with these Riemann sums, these definite integrals, and we're going to spend today really working on how to go back and forth between writing a integral as a Riemann sum or vice versa. Okay, we started that a little bit on Friday. We looked at, there was the steps on the at the top of the previous page. We're going to work with that more today. So up here at the top of the page, you have kind of, the idea that this integral can be rewritten as the limit of a sum. Two key things to know. You got to know how to find delta x, which I think that one's the more obvious one. You have to know how to find x of k. And that's the one that, I know that's the one I have to work to remember how to find. So, okay, number 5. Given the graph of the function, y equals, or f of x equals 1/2 x squared plus 1 on the interval 0 to 4. This exact area can be represented using definite integral notation. So give us another, it's not coming quite as quick as I thought it would, but another couple of lessons, and we'll learn how to do these integrals. We'll learn how to find this by hand, but you can also do this on the calculator. Okay? And so eventually when I talk about integrals, we're going to be doing something called the antiderivative, which is going the opposite way. It's kind of undoing derivatives. It's going the opposite way of derivatives. But so this, as of right now, you could put into your calculator. At the end of class on Friday, I suggested you try that, right? And so, and we'll talk about that down at the bottom there. But we're talking right now, how do we write it as a Riemann sum with 8 equal subdivisions? So how do we write it in this form where it's the limit as n approaches infinity of a summation? Now, let's get some information squared away. What are a and b? What's a? A is 0, and b is 4. Those are always your limits on your integral. And a is the lower limit, b is the upper limit. What's n? Eight, because n is the number of equal subdivisions, yes? Okay. While we're here, I don't have quite as much room as I did in my notes. Delta x. What's delta x? What? 1/2? Yes? Because officially it's b minus a, 4 minus 0, divided by n. And so that does equal being 1/2. It's the idea that you're taking these 4 subdivisions and you would be dividing them into 8 pieces. Delta x says that each of those 8 pieces is going to have a width of 1/2. If this is officially a right Riemann sum, that means when we draw this, so 0 to 1/2, you're drawing from the right here, and my point is at the right. Drawing from the right. And so if you draw your rectangles in here, we end up with something that looks like such. Okay. Excuse me. Now, as we go about finding these pieces, we've got the width here. We've got delta x. What we've got to find here is f of x of k. It's a tongue twister. So let's start with figuring out what is x of k. And if you go back up here, x of k is a plus delta x times k. Well, what do we have here? A is 0 plus delta x is 1/2 times k. So in this particular problem, x of k ends up being just 1/2 k. If you prefer, you could say 0.5 k. You could say k over 2. Now, while we're here, and we can do this now or later, let's talk about what does f of x sub k look like? So that means I'm going to take the f of x function, right? F of x is defined up here. Every place I see n x, I'm replacing it with the 1/2 k, which is what my x of k is, right? So what's that going to look like? It's 1/2 times x squared. So it's going to be 1/2 times, what am I putting in place of x? 1/2 k quantity squared. So 1/2 times 1/2 k quantity squared, and then plus 1. That is what your f of x sub k looks like. And a lot of times you'll just see it left in that form. Okay, it's not really a simplified form, it's just the form that they leave it in. Okay. Officially, then what we're doing here, okay, this is that f of x sub k times delta x, that is your area. And it's your area because this is the height times the width. Well, we have our width, we had our delta x is 1/2. We have our height at x of k, okay? We're getting ready to plug those in. And let's see. Do I clean this one up at all? Not really. Okay, so this is going to be the limit as n approaches infinity. Now, actually, I guess I don't have the limit part written here. Did I just not write it? The limit would be here, wouldn't it? Yeah. I don't know why I don't have the limit there. Okay, so the limit is n approaches infinity of the sum. And so sum, assuming we're doing a right Riemann sum, which we did, k equals 1 to what? K equals 1 to n. What's our n? 8, because we had 8 subdivisions, right? That means there would be 8 rectangles would be summing up.
Why does k equal 1?
Because on a right Riemann sum, we just always start with k equals 1. In other words, you're always going to start by plugging in 1, then 2, then 3, then 4.
Is it different for the left?
With a left, you would start at 0. So, because the idea that on a left Riemann sum, you'd be starting at the very, before it starts counting. So you'd be at 0. Whereas here, it's the first, so to speak. Okay? Okay? Then it is the f of x sub k. We just found that, right? And that is the 1/2 times 1/2 k quantity squared plus 1 times delta x. And delta x is going to be the 1/2. And I don't think I cleaned it up any more than that. No. Okay. I leave it as that mess, so to speak. And there are advantages to seeing this mess because, and part of what we're going to work on today, by looking at this, I can tell you exactly what delta x is because I see my delta x is 1/2 here. I can pull out of this what f of x is because I can see, okay, this k, messy k thing or whatever plugged into 1/2 times something squared plus 1. So I can pull out of here what f of x is. I can see that n is 8. Between knowing that n is 8 and knowing that delta x is 1/2, I can find things like a and b. And those are some of the pieces we're going to work on today. Okay? And part of the reason I said there probably wasn't a whole lot of homework you could look at. I don't know if anyone tried or not, but I didn't feel like there'd be a lot that would be doable. Okay, you ready for the bottom? Use your calculator to evaluate the definite integral from 1 to 2 of x plus 1 dx. Did you guys get that figured out on Friday? Okay. The go-to that I will tell you is it's math menu. Whoops. Math menu, number 9. Okay. And basically you just type it in and make it look exactly like that. Okay. It's pretty easy to do. There's also a shortcut in the alpha F2 menu. It's number 4 in the alpha F2 menu. So, what answer did you guys get? 2.5. Did we figure that out okay? When you pulled up, and you guys all have, we all have the plus calculators in here, don't we? I figured you figured out something in your calculator. Okay. I know nothing. I don't know if I've ever had someone in my AP Calc class with the Casio, so I really don't. I know a little bit for pre-calc, but I know nothing for calc level. So, but it's on there pretty easy.
Yeah.
Okay, good. So, but yeah, you fill in the 1, the 2, the x plus 1, and then you have to fill in what variable here, right? So dx. And you should get the 2.5. Okay. Okay. Find the corresponding Riemann sum for this definite integral. So width. Okay, well, what about delta x? What's A?
1,
What's B?
2,
2. What's N? Did they give us an N value? No. And as we proceed, most of the time what we're going to see is that unless you are given a specific value, N is just going to stay in. Okay? So if we find delta x, b minus a over n, well, 2 minus 1 over n means it's going to be 1 over n. And so you'll see that a lot today when more often typical is that your delta x is something over n. What about x sub k? Let me fill that in here. X sub k is a plus delta x times k, right? So x sub k is 1 plus 1 over n times k, which could be left as that way, or could be left or written as k over n. Okay, so that is x sub k. So we have width here with delta x. Height is f of x sub k. Well, what is f of x?
x plus 1.
Yeah. F of x is your function provided in the integral. So that means f of x sub k is going to be x sub k, so 1 plus 1 over n times k, and then plus 1. I think in mine, I originally wrote it as 1 plus 1 over n times k in parentheses, and then plus 1. Could that technically be cleaned up? It can be. It could also be written as 2 plus 1 over n times k. There's nothing wrong with cleaning up. If we are trying to dissect it, it just makes it a little bit more difficult.
So that's not already the x. Okay.
Either of these are. What are you saying?
And like up here. Oh wait. Never mind, I was looking at the sum one.
Okay.
Never mind. I was looking at the sum where it says f of x sub k already.
Okay.
I got it.
Okay. So C, write the corresponding Riemann sum. Okay, so the limit as n approaches infinity of the sum from k equals 1 to, how many subdivisions do I have? N subdivisions, right? So as we write these Riemann sums, that's your typical response there of f of x sub k. So that is that 2 plus 1 over n times k, or I should have done this earlier. I'm going to write it as 2 plus k over n, if you will. That's f of x sub k times delta x, which is 1 over n. Okay. D, evaluate the limit of your Riemann sum on a calculator. I have not figured out a way to do that on the TIs. So I know you can do it, or not on our TI 84 pluses, I guess. I know you can do it on TI Inspire, but I have not figured out how to do it on our calculators. So either I'm missing it, or it's not possible. So what's it going to work out to be, though? It's going to work out to be 2.5, because it's going to work out to be the same as the integral. Okay, so in other words, this limit and this integral are equivalent to each other. Let's see, there was one other thing.
So it's doing the limit if you did the exact same.
Yes. Yes. No, I just haven't figured it out yet. Maybe I will. Maybe I won't. So I'll be honest, I didn't go back and try and look at it again over the weekend to figure it out. So. Okay.
What do you do with the d and the x when you're on the calculator? You just put dx, or?
Are you talking right here?
Yeah.
Yeah. It's just dx. You're just, so on your calculator it's d and then there's a blank, right? So you're filling in like your variable x. Does that make sense?
So if you use like a different variable,
I mean, it's just, honestly, I can't say that I've ever tried it with a different variable, but it's the idea that when I go to do this, we have 1, 2, whatever variable I put in here in the function. So if I put x plus 1 here, I need to have dx there. Because it's the whole idea of integrating with respect to that variable, kind of like with derivatives. So it's just dx there. I don't know, honestly, I don't usually, so if I tried a different, I don't know, if I was in a different mode, we'd have a different variable. I don't know what happens if you try something, I don't know, wait, that's not what I want to do there. Curiosity, I haven't tried this. So there I put b's in instead of x's out of curiosity. So where I'm assuming if I did x plus 1 here, yeah. So that's where we want our variables to match, because notice I put x in one spot, a different variable in another spot, and it integrates differently because you're going with respect to a different variable. I don't even know how you would do that, honestly. So you can pick and choose whatever variable you want, but if you have x's in the problem, you need a dx at the end. So don't do that, is my point. Okay. Let's see what we can do with these. So example 6. In each of the following problems, translate the definite integral into a Riemann sum. Be sure to check that both forms yield the same numeric values. So when you see that, you can get the answer from the integral, but I do not have a way for you to get the answer from the limit. the Riemann sum, but that's okay. We're not going to worry about that right now because that's not anything I've ever seen us have. It's not something you'd have to do on AP, is be able to calculate or find that limit. So, okay, so we have this integral here. What information can we gather from the integral? A is 2. B is 4. What's f of x? F of x is the function 3x squared minus 1. Okay. We need to find delta x. How do I find delta x?
4 minus 2.
Oh.
Okay. I think your brain was thinking ahead there. 4 minus 2 divided by n. So delta x is 2 over n. Let's also find x sub k. Remember, a plus delta x times k. I'm going to keep writing that down every time for my sake because it's taken me a while to remember that. I'm not sure why, but it's taken me a while to cement that in my head. So let's see, x sub k. A is 2 plus 2 over n times k. I would say it is likely that you would also see that as 2k over n. Okay, I would definitely, I could see him writing it both ways. Okay, we have all the information we need, unless you want to go ahead and plug in x of k into f of x. But I was just going to do that in the problem. So the limit as n approaches infinity of the sum, okay, k equals 1 to what? N. We don't have a value for n. It's unlimited. Of f of x sub k. So we're taking x sub k and plugging it into f of x. So I'm going to have 3 times x squared. So 3 times 2 plus 2k over n, quantity squared. Don't forget the minus 1 in those parentheses, times delta x, which is 2 over n. Are we okay with what I just did there? This is f of x sub k times delta x. And I have this one left as that ugly mess. Yes.
So do you just always start with k equals 1?
Yes.
Alright.
Unless you're given some reason to otherwise. These do not specify, but we kind of assume a right Riemann. When we do Riemann sums here in this situation, we assume right. Okay. I mean, your other option would be if you start with k equals 0, then this goes to n minus 1 is your other option there. Okay. Other questions there? This is the kind of stuff you're going to be able to do in homework, right? Which I didn't feel like when you left class Friday you'd be able to do this stuff. I think you need a little bit of today to get there.
What am I putting for the value?
Oh, the value, in order to get the value here, put the integral into your calculator. So put this into your calculator to get the value. Because I don't have a way for you guys to do the limit of the sum. Trust me, I tried. I played on my calculator. I could not get it to work. So I'm just going to, anytime it asks you for a value, practice using the integral option on your calculator.
an error.
Hey,
I was
James.
just being rude.
Good morning.
Shouldn't matter for this one. Why does that 3 look weird to me?
I guess I didn't need to spin right.
Let's see. It just looks small to me.
Look.
Did you use a negative sign? Wait. Hold on, let me do that again. I'm curious here. Okay, so that's this way. It looks weird. I think you somehow put that in an exponent.
Oh.
So just, yeah, I think you somehow put it in an exponent or something. Like,
That didn't go down from the
yeah, because this is typing a lot bigger this time, I feel like. Because it just seemed weird because it was typing so small. Yeah. I don't know. I couldn't figure out why I was typing so small, but when I hit go to on the air, it looked like you were typing the exponent. Okay, you guys ready to try B? Yes. Okay, Ethan's in a difficult mood. Got it. Okay, what's A? What's B? Do I need to write down f of x? F of x, x plus 3 squared. I don't know. Do I need to write any of this information down, or can you just fill it in on your own? You know. Okay, delta x. Two over n. It's b minus a, so it's 0 minus negative 2, which makes it positive 2 over n. Did we do it backwards? Easy to do, trust me. Let's see, do I have any white out in mind? Okay, I think I did it right that time, but I am definitely guilty of that. So it is b minus a, and b generally, there's exceptions to this, b generally is your bigger value, because the upper limit is generally the bigger value. Okay. X sub k is a plus delta x times k. So let's see, what do we have? Negative 2 plus 2 over n times k, or 2k over n if you prefer. Okay, you ready to write your limit? Stop me if I move too fast. Limit as n approaches infinity of the sum from k equals 1 to n. Typical Riemann sum beginning. Okay, f of x sub k. X plus 3 quantity squared. So I'm going to do negative 2 plus 2k over n plus 3 quantity squared. I think I got an extra parenthesis in there, didn't I? And then, so that's my f of x sub k, because that's putting in x sub k plus 3 quantity squared times delta x, which is 2 over n. Officially, you could leave it like that. Officially, you could also need to simplify it. Remember, when AP is multiple choice, you have to be able to acknowledge multiple different situations, right? What is the obvious simplifying that could be done? Negative 2 plus 3 could be rewritten as a 1 in there. So you could also write the limit as n approaches infinity of the sum from k equals 1 to n, and we could make it 1 plus 2k over n quantity squared times 2 over n. Okay. Tell you what, I don't mind if we have to simplify this, but if you're trying to go the other way, this definitely makes it difficult here. Because now, before, I could look and know, oh, hey, a is negative 2. Now, I don't so easily know what a is. I don't so easily know that my function is x plus 3 quantity squared. So that's why I prefer that form, but AP won't always give you that form. Did anyone do the integral here? Yep. It's 8.6 repeating, or 26/3, I think, is what the fraction would be. So, either or. Okay, one last one in this section. A is 0, B is pi, my function is sine x. So delta x is pi minus 0 over n. So pi over n. X sub k. A plus delta x times k. So let's see, what's A? A is 0. So 0 plus pi over n times k. Do I have to write that 0 when I go to plug it in later? No. You can just write it as pi over n times k, or pi k over n. Okay, either way. Realize, and again, we'll talk about this more in the next section, when there's no plus something, that means A is going to be 0. And that's a good connection to make. Okay, did you get started? Limit as n approaches infinity of the sum from k equals 1 to n of sine of x. So it's going to be sine of x sub k, so sine of pi k over n times delta x, which is pi over n. Did anyone do the math here? The calculator math, that is. Is everyone getting to? Just curious.
Does it change if it's in degrees or radians?
Yep. If you're in the wrong mode, it would matter here. And how do I know it would matter? Because we have a trig function. Anytime you have anything to do with a trig function, your problem, you need to be in radians. So if you happen to be in degrees, you would probably get into trouble here. I'm assuming you would. You'd have, you know. So, okay.
Yeah, it's changing a little bit.
Okay.
Just a little bit.
I figured it should change it up. So, now the others, did it matter if you were in degrees? No, it didn't matter if you were still doing physics. Okay. You guys must not have been changing back and forth on the calculators much lately. So. Okay, next section. Which, I think this is kind of the last section I'm really going to focus on. 8 is, I don't know, section 8 was, there's only about one example I'd even want to attempt with you guys in there because they were rough, so. But, example 7. Okay, we just took all those integrals and put them into a Riemann sum form. Now guess what? We got to reverse it. Okay, so it's time to reverse it. So we have the limit as n approaches infinity of the sum from k equals 1 to n of 5 times 5k over n minus 2 minus 1 times 5 over n. Well, thoughts of anything you can identify?
F of x equals 5x minus 1.
Do you see it? He's saying f of x is going to be 5x minus 1. Because what do you have here? 5 times x minus 1. So what is this right here then? This is x sub k. You see that? So what you've got to realize is that messy thing, that I can't always say it will be messy, but that messy thing plugged in is probably your x sub k. So if we pull that 5x over n minus 2 out, then you can see it's 5 times something minus 1. So the basic 5x minus 1, that thing I pulled out is the x sub k, right? Okay, what else do we know? Okay. Delta x is 5 over n, right? Because what is this supposed to be? This is supposed to be f of x sub k times delta x. So are you seeing all that? And I guess I should, this is getting tricky here. F of x sub k is this whole thing. X sub k is this piece right here. It is. I was just getting ready to say, A is the next thing you've got to find. It's staring at you. You just got to know what to do with it. And here's the idea. Keep in mind that x sub k, when we pull that out there, is 5k over n minus 2. What do we know x sub k is defined as? We've been saying a plus delta x times k, right? So can you pair up the pieces there? Delta x times k is going to be the right here, because we already said delta x is 5 over n times k. So what's that mean the minus 2 has to be? That's your a value. Are you seeing that? So yes, we do know that a is negative 2. We now have the ability to find b. You have to identify a first. Now you have the ability to find b. What do we know about b minus a? B minus a is 5, right? B minus a is 5 because this delta x right here is b minus a over n, right? So b minus a is 5 and a is 2, excuse me, negative 2. So b minus negative 2 is 5, excuse me, b plus 2 is 5, b is 3. You're ready to write an integral. The integral from a to b, negative 2 to 3, of f of x, which we decided was 5x minus 1 times dx. 5x minus 1 is our function. It represents the height of each rectangle. Dx represents the width of each rectangle. Okay, we generalize in integral form to dx, but that's representing your delta x. And you're good right there. I guess it says check both forms gives the same result. So officially it's saying plug this in the calculator and plug that into the calculator. And that's officially your check that you've done it right, if the calculator gives the same on both. This works out to be 7.5 if you've tried it. That's according to what's written in my notes. Okay. Did it kind of come together there? See us starting on the next one, which is good. What kind of things are you identifying here? We know that form is the f of x sub k times delta x. So delta x is going to be 2 over n. What is this function? What is f of x? Three x plus 4. And if she's saying it's 3x plus 4, then that means she's trying to tell me that x sub k is 2k over n minus 2. This form is way too much like the last one. Oh well, good practice, right? Good practice while we get used to it. So, if x sub k is a plus delta x times k, and we're saying that our specific x sub k is 2k over n minus 2. Do you see it? We've got the 2 over n times the k for delta x times k. And so a is negative 2. I promise it's not always negative 2. Okay. What's b? What'd you say it was, 2? Or 0? I thought I heard 2. I haven't obviously thought ahead, so 0. If a is negative 2, b minus a has to be the top of delta x. It's 2. So b minus negative 2. So really it's b plus 2 equals 2, so b is 0. Okay, I think we can write this integral, can't we? Integral from negative 2 to 0, smaller number on bottom usually, f of x, which was 3x plus 4 times dx. Okay, good. A is not negative 2 on the next one.
Oh.
Yep.
Okay, C. We do have one more from that section still. So let's make sure we get through C. Okay, what information do you have for me?
F of x is cosine x.
Okay. F of x is cosine x.
A is 0.
Ooh, she's saying A is 0 this time. Do you see why A would be 0? When we pull out that piece from cosine, this is our x sub k, right? So we know x sub k to be A plus delta x times k. If our x sub k is just k pi over 6n, if there's no plus or minus there, you have to realize that A is 0. And realize that k pi over 6n is your delta x times k. What is b minus a equal to?
Pi over 6.
Pi over 6? Yes, because realize this k pi over 6n, or I guess go back here. Pi over 6n is our delta x, right? So this is pi over 6n times k. And so that b minus a value is actually pi over 6. So if b minus 0 is pi over 6, then that tells me that b is pi over 6. And I think we're ready to write it, aren't we? The integral from 0 to pi over 6 cosine x dx. If you put it into your calculator, you got 1/2. Assuming you were in radian mode. Okay. So I'm kind of at whatever we get through an ABC is fine, because ABC are a more complicated version of what we just did, where these were the more obvious version, which I feel like is what I've always seen on AP, where the function is more obviously there. Not saying they couldn't throw in something tricky on you. When you get down here, it talks about a Riemann sum in simplified form should be unsimplified before translating it into a definite integral. This kind of goes back to, where was I? This one right here. We would really need to take this back to this form before we can talk about what A is and what X sub K is and all of that. And let's just say easier said than done sometimes. Sometimes it's pretty easy, sometimes not. Now, do I have? No, I do not. So I guess we're working it down here.
B is scary.
Oh.
What'd you say?
B is scary.
Yes. Yeah. B and C doesn't look scary, but C is scary. So,
Oh, I didn't see the metric.
yeah.
So if I see something like B or C on
Well,
the AP test.
Okay, and here's why. So if we glance at C real quick. Okay, B is, you have to recognize that is they threw in a sequence there. But C, if we look at C, here's why it's tricky. Your delta X doesn't match up in both places. Delta X in the actual delta X is 8 over N. But in your X sub K form, you see 16 over N.
Whoa.
And so you have to do some serious math there, which is where I'm not sure. I feel like we want to handle that right now, to realize that A is not 1 then. Because that delta X is not in the right form there, A is not 1. And so that's where it gets the extra tricky. I'm just trying to get us through the basics right here, which is why I'm like, that might be a little bit more. Now, as we look at this one, as we try and look at this one, the beginning's fine, right? Limit as n approaches infinity, sum from k equals 1 to n. We've got to figure out delta x. It's not obviously showing. We've got to figure out a. We've got to figure this all out. So as we start looking at this, when we have this square root of k over square root of n cubed. I'm trying to think how.
Square root of X.
Oh, for your function?
Yeah.
Yes, I believe so. The key is we've got that, I'm trying to remember how I wrote it out. Yeah. So the fact that if we think about this as square root of k on top, or square root of k times 1 is actually what I'm going to say. This n cubed on bottom, think about it as square root of n times square root of n squared. The fact that square root of k over n, that's going to get us the idea Megan just mentioned, square root. Okay, yes, square root of x is going to be our function here, but the idea that right there then, I can think of this as square root of k over n times 1 over, what's the square root of n squared? 1 over n. And by separating that out, this 1 over n is now my delta x, and this is my f of x sub k. Seeing that is a whole different ballpark, isn't it? Sometimes it's easy to see, sometimes not so much. And this one isn't horrible, but again, would you have seen on your own the first time through? So what we can realize here is that 1 over n is delta x. F of x sub k is the square root of k over n. So that means that, let's see, x sub k, which is supposed to be our a plus delta x times k, is what? It is just square root of k over n, which means what is a? A is going to be 0. Okay. This is also showing your function by seeing the k over n here. This is showing our function f of x to be the square root of x. Let's see. If a is 0, and what is b minus a? B minus a is the 1, because it's 1 over n. And so that means b is going to be 1. It's a very easy integral to write once you have that, right? So you end up with the square root of 0 to 1 of the square root of x dx. It's being able to see it to pull it apart. Darn, I ran out of time for B and C.
Oh, no.
So not disappointed here.
Okay. Look kind of scared.
I mean, and keep in mind, you do have the answer key. The answer key to the guided notes are in your files, right? So you are more than welcome to look at it, but they were not easy ones to follow. What is the value for that one? 2/3. Your calculator is going to tell you 0.6 repeating if you don't go to fraction mode. Okay, your homework. 1 page, front and back.
Yes, sir.
Woo! 1 through 14. I think there's 2 that you're probably going to be a little confused about because the answer key does magic. But it really comes down to its fractions within fractions that she doesn't show her work on. And that happens, number 1 is going to have some magic on it, and 12. If you do the fractions divided by, fractions within fractions, it's doable. But I think the rest is pretty straightforward.
Oh. What happened?
No.
Good.